Good morning, students. Welcome back. If you remember, in the previous lecture, I discussed the exercise of the first chapter, and with that, the chapter 1 ends. If you're having any other queries, you can once again I repeat, you can send your queries to the concerned teachers. Okay. Now we'll start with chapter 2, physical and chemical changes. It's a pretty easy chapter, and maybe you're having a bit of knowledge about this chapter. So let's get started with the chapter. The term physical and chemical changes over here, they're basically, you have to understand three terms. What are the three terms? By the name itself, physical, you have to understand what is physical change. The next is what is a chemical change. And along with that, the first thing which you have to understand is what the term change means. We have to understand that first, that what the term change means. Let's start. The first is, what is a change? As the word itself, it's basically by the English word, change is variation, right? Something which is the original, that means initial and the final, both will not be the same. As I've written, the entire process in which an action will result in highlighting a difference between the beginning and the end of something. That is, suppose a work is going on, any of the work, or you are doing a work, or I am personally doing a work, or anything, what we are doing or what we are not doing, or any machine is doing, anything, something is going on. So when something is going on, that means definitely it had a start. It started at some point of time, then only it will go on. So when you are seeing or you are observing, you are visualizing or feeling that something is going on, or either it had already started, for that reason you are seeing that the process is going on, or that process is about to start. When a process is about to start or it is going on, definitely it will have an end. That means it will stop at some point of time. If after that particular point of time, if we notice that when it's the point from which it started and the point at which it ended, it stopped. So during the starting time and after the end, or the stopped action is stopped. So before and after, if we notice any difference within anything, then that difference is actually the entire process. That thing is called a change. For example, suppose raw vegetables. We have taken raw vegetables and we cooked it. It can be rather cooking or boiling. Let's consider cooking, or let's consider boiling. Boiled vegetables. So before we took that vegetable that was raw, fine green color or red color or any other color it had. It can be green, it can be red, it can be purple or yellow, all these things. So before the cooking or boiling is done, it was raw vegetables. And after the cooking is done or boiling is done, we are noticing there is a difference. What is the difference? The vegetable is now more soft. The vegetable is now has got a different color. So before the boiling, that means raw vegetable color, and boiled or cooked vegetable color, both are different. It can be, the shades can be lighter, the shades can be deeper, or some other shades before and after the process is done. That is what we call as change. That means we will say that vegetables has undergone a change. It has changed from raw vegetables to cooked vegetables. The rather the what should I say, the components, the material by which vegetables are made up of, those materials were previously hard, and after that now it is pretty soft. So there has been a difference, and this difference is what we call as change. Lights on to lights off. That means before the action has been done. That means lights on and off has to be done. Rather, some driving force is there to bring out this difference, to carry out this process. Some action or some driving force is there. Now, before the driving force was existing, and after the process got over, the driving force is not there, but the driving force has created a difference, has made a difference. What's the difference? Before the application of that force, lights were on. And after the application of that force, lights are off. So this is what we call as change. The next is, obviously, now we have understood what is change, right? Okay. The next question, which is very, very common, or rather very, what should I say, obvious to ask, then where does this change take place? We have understood that what is a change. Now, at what location, what's the specific location does this change take place? The answer is everywhere. This change can take place everywhere, no matter, it's irrespective of the location. So there is not specific site where we can say, no, this particular site there is a change taking place, and that particular site there will be no change, or no change takes place. No, it's definitely not. Each and every place a change can take place. So everywhere a change can happen. All right? When it takes place? Every time. But definitely it depends on the place. Every time it takes place, change takes place, but every time it may not take place at the same place. Every time, that means when it takes place, does this change is having a specific time? No. There is no specific time that this change will take place, or that particular change will happen. No, there is no specific time. There can be a press, more or less there can be at exactly the same. No, it's not that like that. A change will take place. It takes place every time, but it varies from place to place. Every place it takes place, but every place at the same point of time it may not take place. Okay? All right. For example, let us give this example rather when it takes place. Suppose there has been a thunderstorm. We know that every March, April, May, thunderstorms will take place. But does it take place on the same date? No. It does not take place on the same date. That means this year or the previous year, it may match, it may not match. Rather, growth of a child. Every child grows, but that does not mean that all the child will have the same growth rate. Every day, we think of something, but that does not mean that every day we are thinking in the same way. We are thinking on the same topic. No, every day we are not thinking on the same topic. Every day we may not think on the same topic. Every day we may not think in the same way or direction of thinking. It may not happen every day, every time. Every day we are eating food, but every day we are not eating food at the same time. Maybe possible. Every day it is possible that we are not having the same type of food, same quality of food, same pattern of cooking. So it's not that when it takes place, every day we will have our food in the afternoon. That does not mean that we will have it at 2:30 or we will have it at 12 o'clock. The time may vary. Every day it may vary. Exactly the same time, it's not possible. or it is possible then some other works will not carry out on the same time scale. So change is there, but every time it takes place, but it depends on place to place. Now coming to the next, that is types of changes. What are the different types of changes? The first, natural and man-made. The second, periodic and non-periodic change. Third, slow and fast. Fourth, reversible and irreversible change. And the fifth and the last, that is physical and chemical change. As whether it goes with the chapter itself, the name of the chapter, physical and chemical change. So now let us start to discuss all these 5 different changes in a more elaborate and in a more detailed manner. The first I will come to natural change and man-made change. As you can see, this discussion of each and every change, not only with natural change or man-made change, is given as in a tabular form, but rather all the 5 changes which we will be discussing now, all these have been presented to you in a tabular form, so that you can clearly identify the differences between a couple of change, or the set of changes. Okay, natural change and man-made change. Man-made change, as you can see, it's also having a name called artificial change. Man-made and the artificial are all the same. Now, what is a natural change? The natural changes are those changes that occur naturally. That means, and when man has no part to play in these changes. That means, we, the human beings, we will not control, we will not govern these changes. That means, whenever the change will take place, that means the human beings or the living system, will not be responsible for, especially we, the human beings, will not be responsible in bringing these changes. So these changes will be governed by the natural forces and will be controlled by nature itself, and we will not be able to interfere or to control these changes, and hence the natural change. Example, growth of plants. Can we control the growth of plants? Can we control the germination of seed? Can we control storms, cyclones? Can we control these things? That means when the leaf of a plant, exactly when the leaf of a plant will come out, can we control that? By using certain chemicals, we can accelerate the growth of a plant, but can we control it properly, or rather totally? That for example, within one day, we will have the entire fruit, we will have the entire big tree? No, we cannot. We cannot control that. We can only accelerate certain steps, certain growth processes, but we cannot control the entire growth rate of a plant. It's beyond our control. Man-made or artificial changes, by the name itself, that means the changes which are brought about by the human beings, and they play the major role. That means we, the human beings, we will bring out that change. That means we are responsible for those changes, nobody else. So nature will not control these changes, so we will do that. For example, cleaning of roads. Cleaning roads is an example of an artificial change. Before it was dirty, and after that it's clean, so we are doing that change. Making buildings. Nature do not make buildings. Deforestation. Does nature allows deforestation? No, nature do not facilitate, do not make deforestation. Human does. Pollution. Nature do not bring out pollution. So all these are artificial changes. The next we are having periodic and non-periodic change. What is that? Periodic change, the change which is repeating itself in a fixed interval of time, and non-periodic, which is getting repeated at a different interval of time. That means it is not getting repeated in a fixed interval of time. Periodic changes, it is getting repeated in a fixed interval of time, and non-periodic changes, it is not getting repeated in a fixed interval of time. For example, rotation of Earth. We know that after every 24 hours, Earth will complete its one rotation. That means rotating in its own axis. For example, let's consider, suppose you are in Kolkata and the sun is overhead to you. Okay, the sun is exactly overhead to you. You're at home in the Kolkata and the sun is exactly overhead to you. Now the Earth has started rotating, revolving in its own position. It has started revolving. Now when this Earth has started revolving, then definitely the sun position will change. That means we will see the sun the position of the sun is getting shifted. Now, after 24 hours, once again, you will see that above your head, the sun is back. So this is called a periodic change. That means after a fixed interval, once again 24 hours. So every 24 hours, the sun will be on your head, or rather above your head position. High tide, low tide, full moon, new moon, all these are periodic changes. That means there is a fixed time interval after which this high tide, low tide, all these events do take place. A non-periodic change, since it said that the time intervals are not fixed, the change is happening, but the time interval is not fixed. So having an ice cream, it's not that every day we will have ice cream. And if it is every day, that we are having ice cream, then it is possible that at the same time, for example, at 6 p.m. evening, we are having ice cream every day. It's not compulsory, or it's not maybe that every day that at exactly 6 p.m. we are not having the ice cream. It can be before that, it can be after that. So that means fixed time interval is not being maintained. Buying utensils. Do we buy utensils every day? Natural disasters do take place, but is there any fixed time interval that after every 6 months or every alternate year there will be one natural disaster exactly the same date or the same time or the same month? No, definitely not. So non-periodic changes, the time intervals are not fixed. Periodic, they are fixed. The next, we are having slow change and fast change. Once again, time-dependent change. It's a time-dependent change. Slow change, that is, it takes place very slowly. Simple, very slowly it will take place. Slowly means for a process to get completed, it can take hours, 3 hours, 4 hours, or it can take days or months. So it's a pretty long time. It's a pretty long time for a process to get completed. That's a slow change. And fast change, it will happen within seconds or minutes of time interval. It will happen within seconds or minutes of time interval. The next, so for example, weathering of rocks, rusting of iron. Weathering of rock is a pretty slow change. Do you see weathering? That weathering means breaking down of rocks. Do you see rocks getting broken down within few minutes? Now, if you are breaking, that's a different story. That once again, human intervention is there. So without humans are intervening in the process of breaking down of rocks, have you seen that rocks, if you do not interfere, have you seen rocks getting broken down within few minutes? Within just a minute or second, the rocks are being broken down? No. So weathering of rock is a pretty slow change. It takes years for a rock to break down into soil, into smaller rocks, from big rocks to smaller rocks. Rusting of iron. Just within few minutes the iron will rust? No. The reaction involved in rusting of iron, it's a pretty slow reaction. It takes a lot of time to rust iron. Growing of animals. It's within few seconds animals are growing. And that will lead to a serious disaster. It will be a big mess. If animals and human beings are growing in seconds, that means then we will no longer be considered as animals, or rather no longer be considered as human beings. We will be bacteria, or we will be microbes, because they multiply, they grow in few minutes or seconds. They can multiply itself to into hundreds of thousands within few minutes. That's a fast change. So they are involved in that. So they can, but we cannot. So it's a slow change. Growing of animals, it's a slow change. And fast change example, melting of butter. How much time it takes for butter to melt? Does it take hours to melt butter? No, definitely. If you're having a container, probably if you're using, let's consider 50 kgs of butter, and if you say, sir, 50 kgs of butter will take time to melt half an hour or maybe 1 hour, and you have kept the flame low or the temperature very less, then definitely it will not only hours, it will take days. So the completion of the process of melting of butter is a fast change. Filling a bottle, it's a fast change. Filling a bottle, it's a fast change. Lighting a candle, that also a fast change. The next we are having reversible and irreversible change. Reversible change and irreversible change. What is a reversible change? A substance can return back to its original state. That means, suppose, and state, we know in the previous chapter we read about state of matter. And what is a state? So it can return back to its original. Let's consider the starting state is either solid or gas. So reversible changes, a process has happened and the change has taken place, and the substance has converted itself from a solid state to a liquid state. But it can come back once again into its original state, that means into the solid state. Come back. And what about irreversible change? A substance cannot return back to its original state. That means from solid to liquid it has become, but it cannot come back again into the liquid state or into the solid state. So before and after the change, the state has changed, and that state change it cannot be reversed back. Reversible change, most physical changes are reversible changes. Most physical changes are reversible changes. Almost all chemical changes are irreversible changes. Another point is with a reversible change, that is original state. This word original state means in terms of chemical composition and in terms of chemical property and in terms of physical property, there will be no difference from the starting to the end process. That means until and unless it comes back to the original state once again. So it started from ice, went through a change, and it came back to the same original substance once again. Original means the actual substance and the received substance. There will be no difference in the chemical as well as physical properties of that substance. For example, melting of ice, it's a reversible change. Ice is solid, so ice, it melts and it forms liquid. So water in the liquid state and ice is water in the solid state. So solid water melting to liquid water, and this melting, and after this melting once again, if we cool this water and we are getting back the solid water again. So we started with solid water, we are getting back the solid water, and before and after, if we see that the physical property of the solid water starting and the physical property of the solid water after the change, chemical property of the solid water before the change, chemical property of the solid water after the change, no difference in the physical and the chemical property, then definitely we will say that process, it's a reversible change. And if the chemical composition got changed, and the physical properties, if the physical properties may be same, but the chemical properties are not the same, the physical property, if also in that context also, if it may happen that the physical properties also are varying from the initial as well as with the final, then with the initial and the final, the physical properties has changed, the chemical properties has changed, or it may happen only physical properties have changed, it may happen only chemical properties have changed, and hence such changes are called irreversible change. For example, cooking of food, ripening of fruits. Fruits, can we get back the original fruit, that means the raw fruit, once the fruit has ripened? We cannot get back the same fruit in the unripened condition before and after the ripened condition. So we cannot get back that one. So it's an irreversible change. The next is, and finally we are having the physical change and the chemical change. Physical changes, the molecules are, as you can see the difference over here, that means the molecules are rearranged while their actual composition remains the same. So physical changes, there will be a change, the molecular composition remains the same, but the molecular composition remains the same. There can be rearrangement, but their actual composition remains the same with no change in the chemical composition or the chemical property. But chemical change, the molecular composition changes, the chemical property changes, the color changes, the texture changes, the composition, the molecular composition changes. That's called a chemical change. Physical change is highly reversible. Most of the physical changes are reversible. That means it's not that all physical changes are reversible. It's not that all physical changes are reversible, but most of the physical changes are reversible. That means by the application of physical methods, almost all the physical changes can be made, or rather it's easily reversible, and hence the original substance can be reversed back. But with chemical change, it is an irreversible process. Chemical changes, the original substance cannot be reversed back by using physical methods. Physical method means I will just heat it and I'll just cool it. Nothing else. No reaction will take place. So either I can boil it, I can cool it. So I can go with distillation, I can go with filtration processes. So all these, I can filter things, I can distillate things. So all these things, these are boiling, cooling, these are physical methods. And by the application of these physical methods, if I'm getting back the original substance, then definitely those original, that means that's a chemical change. So without application, or only application, if I'm getting back, that's a physical, and if I'm not getting back, then it's a chemical. In the physical change, no new substance is formed, and in the chemical change, always a new substance is formed. Physical change, normally it's a temporary change. It's not all physical changes are permanent changes. No, all physical changes are temporary changes. No. So it's not all. Normally, most of the physical changes are temporary change. Most of the chemical change is a permanent change. For example, Why I'm saying that mostly it's a permanent change? Because if I'm considering a reversible reaction, then definitely the initial and the final, there is a new product is forming, new composition, new product, new substance is forming. But what's that? But is, since it's reversible, so I will be getting back the original substance, that means the reactant once again back. Once again, I'll get back the reactants, and for that, I'll not use any chemical reaction. I'll just change the temperature and the pressure, and I will be getting back the original substance. So for that reason, I mentioned chemical change is mostly permanent. Physical change is mostly a temporary change. Why is it temporary change? Because all physical changes are not reversible. If I'm cutting a paper, then it's a physical change because no new substance formed. The origin and the final substance remains the same. Molecular composition same. Everything is same. But can I get back the original paper back by using physical methods? Definitely not. I cannot get back the original method back. I cannot get back the original method back. Rather, not method, or original paper back by using these simple methods. So that becomes a permanent change. So physical change, but it's a permanent change, an irreversible. So example, freezing of water, melting of wax, boiling of water, etc. Digestion of food, it's a physical change. Digestion of food. Food once digested, can I get back that food again? No. So it's chemical change because we know that reactions do take place inside the stomach. Burning of coal is carbon. And carbon, when it's burned in air, it forms carbon dioxide and water vapor. And thus, can I get back, if I mix carbon dioxide and water vapor, will I be getting back the coal once again? Definitely not. It's not possible to get back. I cannot get back the coal by only temperature and pressure. So I can get back the coal. Rusting. From the rust, can I get back the iron by just heating and by just cooling? Can I get back the actual iron? I cannot get back the actual iron. So that's a chemical change. So with this, it was basically a pretty small chapter, and with this, I will with the physical and chemical change, the chapter I have nearly approached towards completion. So theoretical discussions I already did in this chapter and almost done. In the next class, I will again do a small recapitulation once again. If you're having any queries, that will be answered. You will be provided with a home assignment. And with that, the home assignment I'll discuss in the next class along with other questions and answers for your help. So, thank you for this class. Stay at home and take a very good care of yourself. Thank you.